Hello, everyone, and welcome to another mini sky tonight. So I had a couple of viewers provide me a couple of suggestions of myths they've seen on the internet and or they've heard from different people and or myths they honestly did believe. And I wanted to crack down on these extra myths. So let's dive into these other myths that we have discovered. So myth number one, Earth's distance to the sun determines our seasons. So many people believe that the reason being why we have hot summers and cold winters, it depends upon how close we are to the sun. Because our orbit is slightly elliptical, parts of the year we're closer to the sun and parts of the year we're not. So they believe that the extra heat is just due to the fact that we're either closer or further away from the sun. This is actually not true. This has to deal with the tilt of our planet. It is tilted 23.5 degrees to a point to where the North Pole is pointed towards the star Polaris right now. And I'll explain why right now in the next myth that we're going to talk about. But currently it's pointed towards the North Star, and that 23.5 degree tilt is what determines our seasons. Because that extra tilt stays in the same place, it goes around the sun like this. And with that 23.5 degree tilt, parts of the year, the northern hemisphere is pointed towards the sun, and parts of the year, the northern hemisphere is pointed away from the sun. And so during the parts of the year when it's pointed closer towards the sun, that's where we get more direct sunlight and warmer days. That's our summer. And when the tilt is pointed away from the sun, we get less direct sunlight and shorter days and longer nights. So hence why it's the coldest part of the year. In between the warmest days and the coldest days, we get equal day, equal night, hence the term equinox. So during spring and autumn, we get equal amount of day, equal amount of night, equal amount of sunlight in the northern and southern hemisphere. So it is nice, good temperatures versus really, really hot or really, really cold. So it's the tilt of our planet, whether it's pointing towards the sun or not, that determines our seasons. And to kind of throw out the myth that the distance from the sun is what determines our seasons, we are actually closer to the sun during our winter by a few thousand feet or so, but still we are closer to the sun during our winter time than we are during our summertime. So it actually has to deal with just the tilt that determines our seasons. Number two, and this was the one that was handed to me by a viewer who saw this blow up on social media, that because Mars was going to be so close in its orbit, it was going to be about the same size of the moon. Oh boy, this was a lot to unpack. The moon and Mars will never be the same size, and it can be compounded into two parts. Many people thought, oh, Mars and the moon are physically the same size, and or just because of their relative distances, they will be the same size in the sky. And to debunk this myth, here's a picture of the moon with Mars. That little red dot that you see right next to the moon, that's Mars. As you can obviously see, they are not the same size in the sky. So that blows the myth out completely. And in terms of actual physical size, they're not even close. Mars is half the size of the Earth, whereas in the moon is roughly about a quarter of the size of the Earth. So they're not even close in terms of physical size. So that blows that myth completely out. So don't let social media be your source of information most of the time, because sometimes they toss out a lot of false information. Number three, Polaris has always been the North Star. And this is where I was getting to earlier. Polaris has not always been the North Star. Our Earth, not only is it rotating on its axis, it's going through a process known as precession, meaning it wobbles on its axis. So over the course of thousands of years, roughly about 26,000 years or so, the axis will rotate one full rotation. So currently right now, Polaris is the North Star in the years 2000. But previously, earlier back in ages, the star in the constellation Draco named Thuban was the North Star. So that's why some ancient records indicate why Thuban is so important, because it used to be the North Star. So currently right now we have Polaris, but in further down the line, like several thousands of years from now, it could be a different star. So fortunately for us right now, it won't have to affect us, because this is a process that takes over thousands of years. So roughly 26,000 years, long after my lifetime. So you don't have to worry about it. So for now, the North Star is the North Star, but for now. Number 4, shooting stars are really falling stars. And everybody knows the idea that you wish upon a falling star or a shooting star and you get your wish granted. And it's basically a star that falls from the heavens to grant wishes, so on and so forth, but it's not technically true. Shooting stars basically are bits and pieces of rock or material in space that when they hit our atmosphere, they start to heat up and they burn up. And since they're burning up, going through our atmosphere so fast, they create a beautiful streak across the sky. To us, in astronomy, we call that a meteor. So to kind of blow the idea of wishing upon a shooting star, don't. You are the authors of your future. You hold the pen to the story of your life, so make it an awesome story worth reading. Yes, you can hope and dream, but ultimately, you got to put your hands to the grindstone in order to get things done. But the idea that they are actually falling stars has been proven wrong by the International Space Station. So this is an image taken from the International Space Station of something falling through the atmosphere, and it looks like a shooting star. So it's literally not a star falling from the sky, kind of like Chicken Little, the sky is falling, the sky is falling. No, 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 no. It's basically debris that got caught up in our atmosphere and it burned up. So a meteor. And before you go wishing upon this star, keep in mind it may just either be a space rock, or in some cases it's satellite debris, because there's so many different satellites that we have up there. Some of them have like broken off pieces, or it could be a piece of metal or something, and it falls into our atmosphere. So you may be wishing upon a piece of satellite. So that could throw that idea of wishing upon a shooting star out the window. Number 5, and I get this one a lot. Many people believe that our sun will become a black hole and it will swallow the Earth, that basically it will collapse down into a black hole when it dies and everything in our solar system will be devoured, and the whole world's going to end. Everybody run and panic. That's not what's going to happen. You have to understand what's going on in terms of the life cycle of a star. So at the beginning of the star's life, it starts in the stellar nebula, and gas and dust start to collide with one another and clump together, and those clumps start to get gravity and they start to grab more and more stuff. And as they start clumping together even more and more, they start to become coalesced. They start to compress because they're pulling everything into the same vicinity. And since gas, as it's being compressed, it heats up and wants to push out. So during the early formations of a star, it's doing this gravitational tug of war with heat and gravity. More material is being pulled in, but the gas is wanting to push out. Eventually, it reaches an equilibrium and the star is formed. And when the star is formed, it starts to go through the process known as nuclear fusion. It starts to create its own energy. It doesn't have to necessarily rely on gathering more materials to form. And once it starts doing nuclear fusion, it sends out a gust of solar wind because it doesn't need excess material, and it becomes a star. And around that star, you can get planets and so on. Now, for many stars, they're roughly average size, like about our sun's size. There are some that are very, very massive, but most of them are about our star's size, if not a little smaller. Now, when nuclear fusion occurs, it basically takes lighter elements, rams them together to form heavier elements. Well, for average size stars or low mass stars, they only have so much that they can fuse together. And they like to conserve energy. I honestly think stars are like the best energy savers of the universe, because for how much they have, they try to use it as efficiently as possible. So for stars that are about our size and smaller, they live up to be billions of years old because they conserve their energy and they basically go through the nuclear process very slowly. Whereas in stars that are much bigger than our sun, massive, they have so much that they just go through it so quickly. Live fast, die young is the rule and when it comes to stars. So basically, the more massive you are, the bigger and brighter of a star you are, the quicker you go through your material and the quicker you die. So for the case of our star, once it goes through its nuclear process and it starts running out of some of the lighter elements like hydrogen and helium, it will basically blow up into a red giant phase as it's trying to fuse helium and some of the other heavier elements. And then eventually, when it starts running out of those heavier elements or can't be stable anymore, it will just puff out its outer layers and condense whatever materials it can still fuse down into a tiny little star known as a white dwarf. That will be the remnant of our star. It won't become a supermassive black hole like you see in the massive tracks. It'll just be this little compressed star that's about the size of about the mass of our sun, compressed and about the size of the Earth. That's it. So our sun will never become a black hole. But suppose we were to have a black hole in the center of our solar system, because I know this is a theoretical hypothesis that has been tossed out there that, oh, if our sun was a black hole, we would fall into it. Actually, no. What determines if something goes into a black hole is dependent upon the mass of the object. So if we were to place the sun with a black hole about the same mass and size as our sun, we would still go into orbit. We wouldn't fall into the black hole. The solar system would just get very, very, very cold because we don't have the light, heat, and energy from the star. We're now having to depend upon a black hole, which does have some Hawking radiation, but that's still kind of deadly. So it will just get very, very cold. So we would just continue to orbit and our planet would freeze. It wouldn't fall into the center of the black hole. Sorry. I know that's a lot of doomsday, oh no, what are we going to do kind of moments by different science fiction writers, but that's never going to be the case. So we're good. And fortunately, for when our sun does become a white dwarf star, that won't happen for another 5 billion years. We're good for now. Myth number 6, Copernicus was the first to propose the idea that the sun was the center of the solar system. That is actually not true. In fact, many people believe that a lot of the ancient astronomers, even in Greek times, believed that the Earth was flat. That's actually not true. In fact, it was Aristarchus who proved that the Earth is a sphere and it has a circumference, and he was able to calculate that. In fact, the idea that the Earth was a sphere was proposed by Aristotle, and it was Aristarchus who proved it. And Copernicus was not the first one to propose the idea. He was the first one to revive it and publish it out to the world. The first one to propose the idea that the sun was in the center of our solar system was Aristarchus of Samos. He proposed that all the heavenly bodies went around this central light source because it was supposed to represent Apollo. So he thought, well, all these planets are supposed to go around the light source of our system. But his idea was accepted, but it got ruled out by a more popular view by Aristotle, who believed that the Earth was the center of the system. So he was a man ahead of his time, but it wasn't accepted by the populace. It was then Copernicus who read accounts of Aristarchus, and with his observations and everything, basically revived that idea with further proof. So sometimes a theory back in the day, given a fresher view with modern eyes and better technology, may have better light. Number 7, and this was one that I had seen across the internet for quite a number of times. You can see the Great Wall from space. So the Great Wall of China, this huge, long, enormous structure that crosses a good portion of China, can be seen from space. That is not true. In fact, from the International Space Station, which is in low Earth orbit, the closest that any space object can get without having to worry about being dipped into the atmosphere, you cannot even see it from there, because they're able to see the beautiful continent of Asia in its full glory, but they cannot see specific details on the planet. In fact, this image that you see right here was taken by Alexander Gerst, and in order to get this image, he had to go into the cupola of the International Space Station, and he had to take a telescopic lens, an 800 millimeter telescopic lens on his camera, to zoom in far enough to get this shot of Asia. And within this image, you can see the Great Wall. So I'll do a fun test for you. You're welcome to pause the video, and I'll give you about a minute or so, and try to see if you can pick out the International Space Station, or not from the International Space Station. Can you pick out in this image the Great Wall of China? It is in there, and it's very difficult to see. But I'll give you a minute. You're welcome to pause the video and zoom in if you can to try to find the Great Wall. I know it took me a while to find it. I had to zoom in a lot to find it, and I had to do some map comparisons and things of that nature. I was able to find it, but man, was it tricky. So can you see it, even with a camera that was taken from the International Space Station and it was zoomed in so much? Can you find it? Now, for many people, they think, oh, it's that big, huge, long line that's up near the top. That's actually a roadway. It's not the Great Wall of China at all. As you can see, you have to keep in mind the Great Wall of China was built upon a natural mountain range. So it's not going to have those beautiful, nice, smooth curves that you see in that road there. This is the Great Wall of China. I know, it blew my mind too. I was like, wait, what? That thin little thing is the Great Wall of China? I wouldn't have guessed it. I thought that would have been the mountain range. Like there was like snow-capped mountains or something. No, but that is the Great Wall of China. And like I said, it took me a while to notice it too. And I was like, oh my gosh, that is ridiculously faint to see. And even I couldn't find it easily. So unless you know what you're looking for, it is incredibly difficult to see it unless you are zoomed in incredibly with a special piece of equipment that you're zoomed in to be able to find it. So to be able to see it with your unaided eye is nearly impossible. In fact, if I recall correctly, according to several scientists in NASA, there is no man-made architecture structure that is big enough to be seen from the International Space Station. They said now some like reservoirs and lakes maybe, and that are man-made, and or some islands that were man-made, like the weird shaped islands in the Philippines. It's possible you could see them, but keep in mind these are islands, not like the Eiffel Tower or anything of that nature. So even to see the Great Wall of China is incredibly difficult, and you have to have special equipment to zoom in to be able to see it. So no, you cannot see the Great Wall of China from space. Sorry. And last but not least, and this was a fun one because I got to do some interesting research, we'll leave it at that, that all these weird things happen under a full moon. In fact, the term lunatic comes from lunar, meaning that you go crazy and it's a full moon. Basically, birth rates increase, that the more you're more likely to be born under the full moon. Crime rate goes up because everybody's going crazy, and et cetera, et cetera, et cetera. And people have actually tried to take this into consideration, that maybe the natural rhythms of the lunar cycle may affect the biorhythms of human. And so they actually did studies on this. And I came across of at least 20 papers that did actual studies on this. And I present to you 2 of them that were very well documented. And if you want to go take a look at these particular 2 papers, you're welcome to, and go search them out, and you're welcome to read them. But basically, they looked at what it is with, could the moon's human biorhythms be affected by the lunar cycle? And they compare them to days where like the moon is in different phases. And so after a while, they noticed over the course of a couple of months, they observed no new trends or tendencies. In fact, there were days where the moon was full and crime rate was lower. And they noticed that over several nights and over different months, that there was no real difference in crime rate or birth rates or anything of that nature that could affect the human physiology or psychology or anything of that nature. So in short, the moon doesn't affect you. I mean, it affects you in the sense of that we have our tides, gravitational pulls from the moon that causes high tide and low tide, but that's pretty much it. So to blame that it's a full moon and you're just doing crazy things, it's a weak excuse. So sorry. So these are some of the myths that I have come across and some viewers have suggested. If you have any other myths that you would love for me to cover over, leave it down in the comments. I would love to do a commenters edition of myths versus facts in astronomy. In fact, it would be really cool to possibly do, like, if you wanted to post like pictures saying, hey, is this real or not? I could go through several images that have been posted on the internet proving whether they are indeed real or not. So if you want to give that a shot, leave it down in the comments that you would like for me to cover that. If there's a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.